has to do with factors affecting rates of reaction. And there's several things that we can typically do that speed up rates of reaction. All right, and there's really 4 things we can do. The first thing is raise the temperature. Alright, so if we think back to collision theory, in order for a reaction to take place, molecules have to hit each other. They have to collide with the correct geometry, so they have to hit on the right side. One molecule has to hit the correct side of the other molecule. And the last thing is they have to hit with enough energy that bonds are broken, bonds are formed. Alright, so they have to overcome the activation energy. So by raising temperature, what do? Our molecules have a lot more kinetic energy, so they're hitting more often. So because they're hitting more often, they're more likely to hit the correct side of the molecule. And when they do hit, because they're moving more quickly, they're more likely to have enough energy to overcome the activation energy. So typically raising temperature increases the rate of a reaction. Alright? The second thing we can do is we can increase surface area. Alright, the idea of increasing surface area is if you have a crystal, alright, that's let's say a foot by a foot by a foot, alright, it is 1 square foot, alright. If you're to chop that crystal in half, 3 different ways. You chop it in half from top to bottom, from front to side, and from back to front. Okay, so now you have 8 different cubes because you have 4 on the top and 4 on the bottom. So now those 8 cubes, instead of having 1 square foot of surface area, they have much more surface area. So again, if we go back to collision theory, we need things to hit each other, and whether they're big or small, they're going to hit each other. We need them to hit each other with enough energy. All right. So surface area doesn't help energy, but having more surface area requires or allows more sides of molecules to hit each other. So increasing surface area allows the geometry or their orientation. It allows more opportunities for that. So increasing surface area increases the rate of a reaction. Sometimes because we live in Kansas, you'll see someplace like in western Kansas where they have all the grain silos, you'll see that there was a fire or an explosion. And essentially that is, they put all this grain in and it gets beat up into some fine pieces. And those pieces have a ton of surface area because they're so small. And just a small spark or just anything that might ignite one of them ignites everything, and you have this big explosion because of the surface area is so great that these molecules that are flammable or slightly flammable, because they react with each other, it's like a chain reaction kind of, and just kaboom. The next thing, we can raise the temperature, we can increase the surface area, and the last thing we can do is increase concentration. So concentration is not how hard you're thinking about something, but concentration we learned first semester has to do with how many moles of things we have in a given volume. So concentration is measured in molarity. And molarity is simply moles over liters. And the way we represent this, if we were talking about the molarity of hydrochloric acid, so hydrochloric acid is HCl. Its molarity, we would use brackets, and we'd have some number in there. So if we had HCl, and we said it was 2.5 in brackets, the brackets mean molarity. All right. So if you see a number in brackets, that means that is its concentration. So concentration is moles per liter. So the higher the concentration, the more moles we have in a certain volume. The lower the concentration, the fewer moles. So if we increase the concentration, we have more molecules in the same space. So they're more likely to hit each other. They're more likely to hit each other with the right geometry or orientation. So rate of reaction goes up. The last way we can increase the rate of reaction is by adding a catalyst, okay, or just a catalyst. And what a catalyst does, if we go back to the idea of potential energy diagrams, all right, if we have this potential energy diagram, something kind of like this, so we have our beginning energy, we have our ending energy, and for these molecules to react, they have to have this much energy, all right, to overcome the activation energy. And the way we usually abbreviate that is the energy with a little a, sub a, the activation energy. So our reactants have to gain energy to get to the activated complex and make products. So what a catalyst does is, all a catalyst does is it lowers the activation energy. So it's kind of like if you've ever gone to Colorado and gone I-70 and gone to like Breckenridge and Dillon, there's the Eisenhower Tunnel. So instead of having to drive your car all up that really tall peak, they built a tunnel through the mountain, and it's much less energy. You use less gas because you're going more horizontally than up. So catalysts work by lowering the activation energy. All right, so I'm just going to say lower activation energy. And because they lower the activation energy, more molecules that wouldn't typically have enough energy now do have enough energy, so more of them react. So there's 4 ways that we can speed up reactions. The first way is raise the temperature, the second way is increase the surface area, third way, increase the concentration, and the last way is to add some kind of catalyst.